One new feature of CA App Experience Analytics is the Data Studio. The Data Studio allows you to create custom visualizations with the ability to visualize your data in various charts, tables, and maps. Data Studio uses an Elasticsearch-based data repository. Elasticsearch is an open-source, RESTful search engine built on top of Apache Lucene and released under an Apache license. It is Java-based and can search and index document files in diverse formats. Another feature of the Data Studio is blueprints. Blueprints are the out-of-the-box reports with Data Studio that help an end user get set up and running with minimal amount of time. They can also be referred to as customizable dashboards. Blueprints contain specific visualizations for monitoring and managing applications. Blueprints can be edited to suit your ad hoc reporting requirements. Some of the available blueprints are Browser Overview, Browser Performance Overview, Browser Sessions Overview, and Unique Browser Details, to name just a few. Blueprints allow you to view metrics, change visualizations, customize filters, and export your visualization data. In the following demonstration, the Chief Marketing Officer for a really big corporation needs to understand which browser to invest in for the best optimized experience. You will see how we use blueprints for ad hoc reporting by first creating a discovery search, second creating custom visualizations, and then customizing the dashboards to meet our specific needs. The new Data Studio tab is located at the bottom of the menu of CA App Experience Analytics. There are three options under the Data Studio tree: Discover, Visualize, and the Dashboard. Kibana uses index patterns to access data. Index patterns are used to identify the Elasticsearch index to run search and analytics against. They are also used to configure fields. In the CA App Experience Analytics instance of Kibana, the index patterns for your data are already defined. The time filter restricts the search results to a specific time period. You can set a time filter if your index contains time-based events and a time field is configured for the selected index pattern. By default, the time filter is set to the last 15 minutes. You can use the time picker to change the time filter or select a specific time interval or time range in the histogram at the top of the page. We will set the time filter for the last 30 days. Since we are interested in browsers and web apps, we will choose the page index pattern. We can see the timestamp and all of the available fields. We select the browser type so we can concentrate on that field column. Notice we can now see the browser type and date stamp. We will view the document data for all of the available fields. We will now set a filter based on the browser type field column. The query will select the 500 most recent documents that match the query. We now see the field data statistics. To add a filter, click on the plus sign and the filter icon will appear. By clicking Actions, we can enable and disable filters, pin and unpin, invert, toggle, or remove filters. You can also use the custom filter option. Click this icon to display a text field where you can customize the JSON representation of the filter and specify an alias to use for the filter name. Clicking on the trash can icon removes the filter since it is no longer needed. We will now save the search for the page data index so we can use it for visualizations. The CA App Experience Analytics instance of Kibana does not support the deletion or renaming of existing objects. To rename your objects, save them using a different name. You can also open, change, and resave existing objects. We will be using the browser overview later to obtain the data that the Chief Marketing Officer has asked for. You can use the visualization page to design data visualizations. You can save these visualizations, use them individually, or combine visualizations into a dashboard. You can create and customize your visualization using the following options: area chart, data table, line chart, markdown widget, metric, pie chart, tile map, or vertical bar chart. For this demonstration, we will select pie chart and use the search we saved earlier. The slice size of a pie chart is determined by the metrics aggregation. In this instance, we will use the count aggregation. The following aggregations are available for this axis: count, The count aggregation returns a raw count of the elements in the selected index pattern. Sum, the sum aggregation returns the total sum of a numeric field. Select a field from the drop-down. Unique count, the cardinality aggregation returns the number of unique values in a field. Select a field from the drop-down. The buckets aggregations determine what information is being retrieved from your data set. You can specify any of the following bucket aggregations for your pie chart: date histogram, range, date range, IP4 range, terms, filters, or significant terms. We will use terms. A terms aggregation enables you to specify the top or bottom n elements of a given field to display, ordered by count or a custom metric. We will now choose the browsertype.ras data field. Raw or formatted links are at the bottom of any of the detailed information tabs. A raw export contains the data as it is stored in Elasticsearch. A formatted export contains the results of any applicable Kibana field formatters. After changing the options, click the green Apply Changes button to update your visualization. Now we can see the data in the pie chart. We will add a sub-bucket to show the browser versions on the pie chart. This time we choose the browser major version.raw field, and we will increase the size to ensure we see all the browser versions. After changing the options, click the green Apply Changes button to update your visualization. Now we see both the browser types and browser versions. By clicking on the Save Visualization, it allows us to save the new browser's visualization. We will now build a custom dashboard based on a blueprint to capture the data that the Chief Marketing Officer has requested. We will use the Browser Overview Blueprint as a starting place. The Browser Overview Blueprint provides page request information, page sessions, browser type and version, and page map. The default time filter for Browser Overview is the last 7 days. We need to change it to the last 30 days. We can use a quick, relative, or absolute time filter. We will use the relative time filter for this request. We will select the option for the relative time filter to round to the day. The filter is activated by pressing Go. We want to use the browser pie chart visualization we created instead of the one provided in the blueprint. Click on the X to remove the default visualization from the dashboard. To make room for the browser's visualization and an app ID visualization, we will adjust the size of the page sum request and page sum sessions. By pressing the plus icon, we can add visualizations to our dashboard. We choose the visualization by typing its name in the filter. We now choose our app ID visualization for the dashboard. Note, the wchapp.id is placed in the first available space large enough to contain it. Now we search for browsers. We will select Browsers, the visualization we created previously. After adding the two custom visualizations, we see there are two applications, TixChange and Tomcat Test App. We can also see that there are three browser types, Chrome, Firefox, and Safari. The fifth visualization, Page Map, is a tile map often used as a heat map. The page map shows us locations where the users are accessing the applications from. To look at the browsers used for the TixChange application, we click on the TixChange slice of the App ID visualization, which then creates a filter. The dashboard now shows all of the data corresponding to TixChange. By clicking the caret symbol on the browsers, we can see the data in a table format. We download a comma-separated variable file, CVS, so we can inform the CMO of the details. We now export the formatted data. The CVS files give a clear understanding of which browser and browser version was used the most over the last 30 days. We then invert the filter to show the other applications so we can export the browser data. After inverting the filter, we now see the data for the Tomcat test app. We can then export the browser data for this application. Note that the pie chart corresponds to the data we downloaded. We do not need the filter any longer, so we will remove it by clicking on the trash can icon. So we do not have to recreate this dashboard, we will now save it for later use. Store time with dashboard is selected, so we will not have to set the time filter the next time we use the dashboard. We have created a discovery search, created custom visualizations, and then customized the dashboards to meet our specific ad hoc reporting needs.